Aleo? We'll have Anthony next from Aleo.
Hello everyone, it's great to be here in Seoul. This is my first time here. It's been an amazing experience so far, and I'm super excited to check out Seoul and see all the amazing things that people are going to be building and working on. And after this presentation, happy to talk with other people about what we're doing at Aleo and how you potentially get involved. First thing I just want to start with here is I'll just put out a slight apology for the theme of some of these slides. It's Paris themed. Obviously we're not in Paris right now, but we just presented these at ECC. And so yeah, we didn't end up changing some of that, but just wanted to say that to start. And yeah, so my role at Aleo is I'm head of growth, so I'm primarily responsible for managing our grants program, handling business development, other strategic partnerships with various projects. And I am actually standing in place of our co-founder, Howard Wu, who actually put together a lot of the amazing technology behind Aleo. And so I apologize if I can't answer every single one of your questions, but I'll try my best. Do you know which button I have to? Okay, here we go, sorry. Okay, so you can skip that. So to start, essentially, what is Aleo at a high level? It's allowing users to run zero-knowledge applications on the web. So at the end of the day, we want to enable web developers from the Web 2 space to come into Web 3 and build any kind of arbitrary application on Web 3. That's kind of our ultimate goal. And within our ecosystem, we have a number of different players. On the one hand, you have developers, which is maybe somebody such as yourself in this audience. They're the ones that will actually write these applications, and then they'll send execution requests to what we call provers on the system. These are the people that are actually running the application for you. And then those provers will then broadcast transactions to validators, and then in our system, validators are the ones that are actually hosting these applications, and then those validators will send an execution response. So at a high level, these are kind of all the players in our ecosystem, and I will be walking through each of those players and how they specifically operate in more detail. But just so you can get a high level, that's kind of what we're looking at here. And so the first thing I want to talk about is networking and propagation on the Aleo network. So essentially, if you want to imagine the network topology at Aleo, it's structured where you have a core of validators at the center, which are then surrounded by a loose structure of other node types in our system. And again, we'll kind of talk a little bit more about that as we go through this presentation. And in Aleo, we'll be using a modified version of the CAD-CAS protocol, which is based on Kademlia, to construct an efficient and reliable broadcast. So that's really important for us. And then the other important thing to note is that propagation should only require one message received per node, so that we have little to no duplication required. And so, yeah, the proof system that we actually use in Aleo is something called Marlin. We're actually using a combination of Marlin and something called Lookup. And basically the entire purpose of this proof system, along with Lookup, is to reduce the constraints by pre-computing expensive functions. So you can almost think of Lookup as sort of like a cheat sheet for Marlin to reference, and then Marlin itself, roughly what it does is it reduces every computer program to additions and multiplications. And again, like integrating Lookup gives the prover, which I talked about earlier, access to a set of constant values. So by having this combination here, we actually, again, are able to reduce a lot of the constraints in our system and make Marlin a lot more efficient, which I think is really, really key to Aleo's architecture. And so Marlin, there's also this notion of like batch proving in our system as well. So with batch proving, what you do is you're proving a batch of executions all together. This reduces prover time, verifier time, and proof size. Again, it's really important. The important thing to understand about zero-knowledge proofs in general is that they are currently extremely expensive to generate, and they're not super efficient. So with this batch proving, we're trying to improve that, and then there's also many other ways in which we're trying to do that through a consensus mechanism, which I'll talk about, and then this other initiative that we're running called ZK-SEL, which maybe we can talk about at the end. And then again, here it utilizes parallel composition of polynomial IOPs to reduce redundancy. And so, for example, this creates greater than a 4 times reduction in prover time for 4x4 transitions. Another really interesting thing that we've implemented is threshold signing. So the high-level concept here is if you want to, generate a private key, there might be multiple different signatures that need to be used for that. And so here you can see we aggregate n signatures into a single signature. This is actually really useful for proving that a group of signers have agreed on a statement or decision. It's also great for compression, right? So storing one signature instead of many different signatures. We've actually implemented the Frost threshold signing for Aleo curves and address scheme. So again, I think this is like really important to have in our system, and it's something that we've recently been working on. And so going back to like our consensus mechanism, so one aspect of it has to do with this concept known as a coin-based puzzle. So I don't know how many people are familiar with Aleo already or who were in our testnet during our testnet 2, but basically up until recently we were only implementing something called proof of succinct work, which is actually based on core components of SNARKs, which stands for Succinct Non-Interactive Arguments of Knowledge, if you're not familiar. It's a specific implementation of zero-knowledge cryptography, and it has to do with FFTs and MSFs. And so basically, with this coin-based puzzle, what's happening is we are minimizing the moving parts to achieve a puzzle so that it's robust to amortization. And again, ultimately we just want to achieve a smaller proof size than the existing Marlin-based proof of succinct work. And this is actually an important component for provers in the system, which again we'll get into in a separate slide. But the general idea here is that with solving these coin-based puzzles, these provers can actually generate zero-knowledge proofs that individuals who are running some program on the network can actually leverage. And again, this is part of our larger consensus mechanism, which we'll talk about a little bit more, which also has a proof of stake component to it as well. And so now that you have some of that background context, the next thing I want to talk about is our current testnet. So this is testnet 3. So I mentioned we had testnet 2 before. In testnet 2, we were mainly focused on just having individuals mining on our network. With testnet 3, we're actually going to be doing a lot more and having more people involved in the ecosystem than just miners. So we actually already started phase 1 that began August 1st. Just as a disclaimer, the testnet 3 is actually up internally. That actually happened on August 1st. We're hoping that like early next week, or shortly following that, we'll be able to open up testnet 3 to the wider ecosystem. Essentially what we're waiting for is we're adding some finishing touches to a few different components, specifically our Explorer. So once that's ready to go, I think we'll be pretty confident to get this out to the public. But essentially, once the Explorer is finished in this first phase, there will be 3 phases to testnet 3. Aleo will basically bootstrap the network with a bunch of Genesis beacons, and then anybody will be able to participate by running a client. So any of you can, join the testnet and start running a client. And then the really cool thing is that developers will actually be able to deploy and execute programs. And if anybody's interested in doing that, again, highly recommend you join. We'll actually have a whole incentive program behind this, which we'll be putting out in a blog post relatively soon. So if you're interested in participating in some incentive program and you want to kind of see what it's like to actually write, run, and deploy an application on Aleo, you should definitely get involved in testnet 3. And you can talk to our team afterward if you want more details on all of that. So the second phase for testnet 3, that's scheduled to happen on September 1st. And so in this phase, it's mostly going to be focused on the provers that I talked about earlier, solving those Coinbase puzzles. And again, you'll be able to earn credits on the network in the testnet for that. So if you're somebody that's more interested in like the proving side of things, not so much like the validating side of things, then this would be a good phase to get involved in. And then we'll also have a bug bounty for SnarkOS and SnarkVM, which will be open to the public. Again, that will be incentivized as well. And I think we're already talking with a number of different projects that will be participating in that program. We'll also be partnering with some of the major organizations out there that facilitate bug bounties so we can get it out to a larger audience. And SnarkOS is our operating system, and SnarkVM is our virtual machine. And then the final phase will happen on October 1st. So our consensus mechanism, which is called Aleo BFT, will launch. And then any prover with 1 million Aleo credits will be able to become a validator. Again, we'll release more details about how that distribution will work. But in this phase, it'll mostly be about people that want to do validation. So a delegating stake will be enabled. So again, if you're more interested in like being a validator on the network, joining during phase 3 could be a really good opportunity for you. Okay, so building on Aleo, I'll try to run through this relatively quickly just so we have time for questions. But basically, again, kind of like what I said, the high level, Aleo, decentralized platform for zero knowledge applications. If you want to think about it, right, you have projects like Zcash, which are really private, but not super programmable. They kind of create this concept of private money. You have Bitcoin. It's neither of those things. It's not private. It's not really programmable, right? But kind of come up with this concept of public money. Then you have Ethereum, right, which came up with the whole concept of like dApps, right? Very programmable, not super private. What Aleo is trying to do is marry the best of both worlds with Zcash and Ethereum. So create something that has the privacy of Zcash, programmability of Ethereum. And if you're in the Ethereum ecosystem, you probably know this, but it's very difficult to achieve privacy in the system. And then what's cool here is that we have zero gas fees needed. There are transaction fees in our network, but you don't need to worry about gas. And we have unlimited application runtime, which I think is obviously super useful for people that want to run complex applications on Aleo. Another cool thing is that we have our own programming language called Leo. So essentially, you as a developer, you can write a program in Leo. Leo is structured similarly to languages you might be familiar with as a Web2 developer, such as like JavaScript or TypeScript, right? So it's very easy to onboard into. And then you can actually run your applications. Well, provers do that, kind of like what we talked before. And then you can actually deploy your application to our blockchain. So everything's kind of built natively into our system. And here's just kind of a visual of the relationship between these three players that we highlighted earlier. So you kind of want to take a look at that. I sort of discussed this already, but that's kind of how the general ecosystem is working. And then, yeah, just going over how to programming on Aleo. So step one is just deploy an Aleo program on chain, right? So you have a transaction as a deployment. Consensus admits, you have your Aleo program, which is as like a program registry, where we compile opcodes, and then a synthesizer produces a proving and verifying key. Idea behind proving and verifying key, it's sort of, the verifying key is used by a validator, and then the proving key is used by the person that's actually deploying some specific transaction. Step two, you execute an Aleo program off-chain. So an Aleo system, essentially what you would do is these provers can generate your program off-chain, right? You generate a zero-knowledge proof, and then that zero-knowledge proof is actually what gets uploaded on-chain. So this is actually good for scalability and also the privacy aspect that we talked about before. And then step three, you can finalize your program state on chain, so kind of what I was saying here. So you have your executed transaction, consensus checks, validators, encrypt the data, and then, so this is a typo, it should say validator outputs, not prover outputs, then you get like your end caller response. So that's sort of, yeah, the high level of programming on Aleo. And then, yeah, so together Aleo allows users to run these applications on the web, like we said. Validators are primarily using Snark OS, our operating system. Provers are virtual machine, and then developers will be primarily using Leo. And yeah, again, so just to kind of extrapolate this a little bit more, we actually have something called AVM bytecode. This is hosted on a chain, right? So you have Leo, high-level programming language, compiles to Aleo instructions, which is more like an assembly-like language, which goes to the AVM, which is actually just bytecode. So that's kind of how everything is sort of working there. And yeah, here's sort of an example of what like Aleo instructions could look like. So you have your main function at the top here. The second line, you have an input of a public register R0. The second line, you have a private input of a private register R1. You multiply those two things together, and you get an output of a combined private register. And yeah, here's a more in-depth kind of look at what this kind of a program could look like in our system. But with that, I think, yeah, I ran a little bit into the question time. So I'll just leave it at that, and I'll open up the floor to any questions. But yeah, again, thank you for coming out here tonight. And yeah, happy to answer any questions you may have.
So we'll take questions from the audience first. Does anyone have?
Yeah, so I'm trying to understand the use case for Aleo. So as far as I understand, Aleo provides that JavaScript-looking language, Leo, and it has this private blockchain network. And that private blockchain network was confusing to me because blockchain, by the nature of it, is transparent. But Aleo provides private network, so you could stop MEV and arbitrage.
Yes. Yeah, so that's actually a very good question. So if you think of blockchain architectures today, there's this big misnomer with a lot of the community that everything is fully private, right? And I mean, you just point out that's not the case. Like the classic example Howard always likes to use is today, if I give you my bank account number, you don't know like how much money is in my account, you don't know how much money I make, like you just know that I'm the owner and I can send you funds. If I give you my public key, you can go to, like if it's on Ethereum, for example, you can go to Etherscan, you can see all the transactions that I had. And these systems are what people call pseudonymous, right? So maybe I don't know that the public key is associated with you specifically, unless obviously you tell somebody that, or you use like some like Ethereum name service or something where you're actually sort of like not doxing yourself, but removing like privacy. Or if you use a centralized exchange, right? If you set up a Coinbase account, right? They generate the public key for you. You have to do KYC. Now they can connect you directly. So in Aleo, essentially what we're doing is we're getting rid of all of that and enabling full privacy. So in our system, we say it's private by default. So every transaction by default is completely private, and then you as an end user have the option to selectively reveal information about a specific transaction.
Did you mention that you guys have Block Explorer, like Etherscan?
Yeah.
So would it also be private if I opt in for the privacy?
Yeah, so on the Block Explorer, again, everything would be private by default unless there were like certain parameters that were selectively revealed. Or you could also maybe think about it as like if you're a developer and you're writing some program, like you could also structure it such that depending on whatever the application is, maybe there's certain information which has to be like publicly revealed. Maybe if we're talking about some like financial use case or something like that. So from the very start, you could maybe specify like, oh, out of all of these parameters, like parameters 1, 2, and 3 will be public, but the rest of it will be fully private. So you have that optionality, and that would be kind of what would be reflected in the Block Explorer.
I see, thank you. Is there any dApps that's currently building on Aleo?
Yeah, so we have a number of projects that have been building in our grants program. So we had one team that was working on a private voting system. So if you've ever heard of Macy, it's like this voting system on Ethereum that Vitalik has always talked about. Somebody was actually building that because in Aleo, again, you get this full privacy, which you can't get in Ethereum, so somebody was working on that. Private fundraising DAOs, people were working on, which I think is super interesting. There's a lot of identity use cases that people have been exploring, so we worked with a project called Spruce ID that was doing like a verifiable credentials project, right? So, being able to issue a credential on yourself without having to explicitly reveal all these details about yourself, but still validating like, oh, okay, this is my profile, for example. So yeah, those are some of the use cases, but we're really interested in like private gaming, again, like private DeFi, yeah, all these different areas.
I see. Thank you.
Yeah, so using Aleo, looks like we're going to have the proof generating execution to someone else, which would be very nice if the prover is honest, but if not, you can go very long. Is there any mechanism that you design to constrain the prover from disputing secret values that will be iterated into the circuit generated?
Yes, that's a good question. I know one thing that we've talked about is like having like these ZK Oracle networks to help with like, I guess sort of the like data availability problems. Like when provers generate these zero knowledge proofs, we can actually validate that like, okay, the inputs that were used to generate the proof are actually like legitimate. And then when you just like the proving and verifying key setup, like all that would sort of be checked. At the circuit level, I'm not 100% sure, but there might be some other members of our team that you could talk to later who could maybe answer that question a little bit better for you. But I know it's definitely like a challenge with some of these systems that are focused on like privacy and generating zero knowledge proofs. But yeah, we've been looking into like a lot of different solutions for that.
Yeah. We're running out of time.
Okay.
So thank you, Anthony. We'll